responsibilities and obligations.
Just 20 parts can make a Superhet receiver. Keep watching to learn how you can build one yourself. A few days ago I saw a video from Mike WU2D describing a autodyne detector for a Superhet receiver. Very simple, just one transistor. I built it and it actually worked first time. So what is an autodyne detector? It's been the core of simple AM transistor radios for at least the last 60 or 70 years. One transistor does all the work, a local oscillator as well as a mixer. Its function is to convert incoming signals on the AM broadcast band with an internally generated local oscillator signal between about 1.1 and 2.1 MHz to an intermediate frequency of 455 kHz. Essentially a front end or converter section. To actually hear signals, all you need to do is to add a diode detector and some high impedance headphones, and provided you're not too far away from a broadcast station, that is enough to hear signals. Very, very simple, one transistor Superhet receiver. How could I do better? Well, one possibility, if you really did want to keep it to one transistor, is to try a reflexing arrangement. That is, you take the audio coming through the detector diode and you feed it back into this transistor again. So as well as it being a local oscillator and a mixer, it's also an audio amplifier. To do that, you need to separate RF from audio signals. You can do that with a combination of capacitors and RF chokes. I've described reflex receivers before in other videos where they're mainly direct conversion receivers, but the technique also works with Superhets. Another approach, because transistors are so cheap, is to try a improved detector. That's actually simpler, easier to troubleshoot, so that's what I've gone for here. This detector is described on a website, a lot of other links and circuits for other things you might find interested in radio, but anyway, it's a Russian website, V. Polyakov, a very famous name in radio circuit design. I'll have a link to both Mike's video and the Polyakov website in the comments on this video. There were several detector circuits. One of them just had one diode and one transistor. It worked definitely better than just the single diode on its own, but as is explained, if you change the circuit a little bit, add a second diode, you get much more output, which I proved was the case when I built this and was experimenting. There is a bit of distortion. You can't have everything in a simple two transistor radio. Still, these two transistors is enough to drive headphones, provided they're off the right type, and I'll describe that in a moment in more detail later, on local stations up to 50, 60, 70 kilometers away. Not only that, but it's possible to receive those stations without an external antenna. That's what made portable Superhets so attractive for pocket receivers. If you want to receive stations with just the two transistors and without an external audio amplifier, you do have to be a bit selective in the type of headphones you use. The output from the detector is high impedance, and so should the headphones for best results. Suitable types include these ancient 2000 ohm crystal set type headphones. They're probably 70 or 80 years old. They are high impedance, they are a good choice. This crystal earpiece, that's okay. Again, high impedance. These headphones, Sony type, they do work, but much weaker than with the high impedance headphones. It is best to connect both parts of the headphones in series. which you can do that if you've got a suitable stereo socket and you just connect the middle and the tip, and that puts the two halves left and right in series. But as I said, not very satisfactory. Alternatively, if you don't have either of those, you've got what looks like a stethoscope, and it is in fact a modified stethoscope. What I've done is I've used a piezo transducer, not a piezo buzzer, but a piezo transducer that has a high value resistor connected across it. I've described this in a previous video, but with the transducer glued right up to the stem of the stethoscope, that gives you quite a good high impedance headphone. And I've used it successfully on crystal sets. It gives quite a good output level, and it certainly works very well on this receiver as well. So just a few tips here on suitable high impedance headphones you can use with this receiver. Or, as I suspect most people will do, just use an audio amplifier. You can use a circuit board. Some have even used solderless breadboard, provided the pins are spaced right. I've just set this up al fresco. All in the air. Some of the wires are a bit longer than they need to be. Some of the wires are a bit longer than they probably should be. Still, it does work, even though it looks a mess. Incoming signals are picked up by the ferrite rod, and the ferrite rod is a sort of an antenna that concentrates the signals, so you don't need an external antenna. And that provides the first tuned circuit, which is tuned to the frequency of the incoming signal. Here's a look at the actual ferrite rod I've got. 80 turns. This is enamelled copper wire. It's close round. The thickness of the wire doesn't matter very much. It's probably about 0.4, 0.5 of a millimetre. The enamel is insulation, so you do need to scrape off with a knife every time you want to make a connection. And so I've got little taps here with little loops every 10 or so turns, 80 turns total. And the purpose of these taps is, especially with crystal sets, you often want to tap the diode or antenna off on one of these to provide the best sensitivity or selectivity for your area. Anyway, I'm just using one of the taps here. This is 10 turns up from the bottom of the coil, and then there's another 70 turns or so to the top. Top of the coil just goes to the steel plates of this variable capacitor. That's basically the stator plates. These other plates here are the rotor plates connected to the spindle, and it's the spindle of this variable capacitor that is typically earthed to the frame. Now, speaking about the frame and earth, that goes not to the bottom of this coil, but to 10 turns up from the bottom. So you've just got 70 turns through here, forming the front end tuned circuit for this receiver. Then there's some coupling to the transistor in the autodyne detector from these 10 turns at the bottom, and that goes via a coupling capacitor. Not clear here, so I'll just go back to the circuit so you can get a better idea. The bottom of the coil goes via this 33 nanofarad capacitor to the base of the autodyne detector. You can see there 47K, 10K provides DC bias for the base. This coil here, this is the red one, is the local oscillator. There's 5 connection points. I'm only using 4 of them. There's 2 coils here. This coil is connected in parallel with the variable capacitor that's used to select the station. So yeah, there's 2 variable capacitors in this circuit. There's the local oscillator variable capacitor that covers between 1.1 and 2.1 megahertz, and the variable capacitor that peaks the incoming signal. Normally in a commercially made Superhet receiver, these would be made as a ganged capacitor. That is 2 capacitors on the one spindle. I'll just show you an example here. The smaller capacitor is the one that changes the local oscillator. It goes from 1.1 to 2.1 megahertz. The larger value capacitor is the one that adjusts the front end, and it's the larger value one that is connected to the ferrite rod. I could have done that here, but you do require exact tracking and coordination between the 2 capacitors, and that means you need to be careful with arranging the inductance values both for the front end and aligning for the local oscillator, which is the red can. You can't see that it is red, but it is this can here. I'll skip the aligning because I'm fortunate enough to have 2 variable capacitors. I've got 2 spindles. We'll have the capacitors separate so that you don't need to do any aligning, but you can use these to obtain peaks on signals. So you have to select stations with the local oscillator and peak them on the front end, and that can be quite awkward. It may mean that you may miss some of the weaker stations, so it's not practical in a commercial product, but for a demonstration project like this, then it's fine. Now this is the red can for the local oscillator. You've got a tuned circuit here, as well as a little coil. This is the secondary part of it on the other side of the can, and that is in the collector circuit of the autodyne mixer oscillator. And it is through here that power is applied. In fact, it's also through the second coil here. This is the yellow IF transformer. This is the positive supply rail, so you've actually got power, the supply, going through these windings on these transformers. And the thing is, with the collector here, you've got a tuned circuit here, which is the 455 kilohertz intermediate frequency, because this is a stage that's converting the incoming signal. It is, you've got the local oscillator signal here, you're subtracting the incoming frequency, and you are providing a difference at the intermediate frequency. And that intermediate frequency remains constant for all the stations you tune in. So therefore, if you want to change the station, you have to vary the frequency of our local oscillator here, as well as following along with our front end to make sure that signals can pass through and be converted without attenuation. So even though it's very few parts, quite a lot happens in this autodyne detector. Here is the underside of the IF transformer. I've showed one separately because my circuit is so hard to see that. Anyway, there's 5 connections, and it's really important you get those right. You can see in the middle there's the tubular capacitor, which is what brings this to resonance on 455 kilohertz. On the primary there are 3 connections, bottom, middle and top, and on the secondary there are 2 connections. The oscillator transformer is similar, except there's no central capacitor, but again there's primary and secondary connections. If the oscillator doesn't work initially, then maybe try swapping these 2 on the secondary around. That might do the trick. When you look inside an old Superhet receiver or tuner like this unit, you'll notice these IF transformers. There are different colours and they are quite significant. There's a general convention. This red one here is the local oscillator, which is an important one. That's a smaller inductor that, in conjunction with the tuning capacitor, allows you to select the stations. It covers 1.1 to 2.1 megahertz approximately. Then we've got other IF transformers, typically have a primary and a secondary winding. They may have taps on them as well, depending on the circuit. Often they have tubular capacitors built inside them, so you don't need to provide those capacitors in the circuit. But anyway, the important colours that we need for this particular receiver is red, which is for the local oscillator, and yellow, which is for the intermediate frequency. These other ones, white and black, are also intermediate transformers. That's first, second, third. But in my circuit, we just need the yellow one. If you're salvaging it from an old radio, just be careful with the soldering iron. You don't want to overheat them. Normally these have 5 or 6 connections, plus also the connections for the metal can, which provide shielding. If you don't have suitable receivers to salvage, you may still be able to get coil packs. This is a particular one from JCar, which is extremely suitable for this project. You've got the red coil there, the connections are marked, and the white yellow coil. How can you tell that your local oscillator is working? Well, easiest way is to get a simple AM radio like this, put it on about 13 or 1400 kilohertz AM, and vary the local oscillator tuning on your receiver. And you'll find a point, if it's working, where the receiver goes quiet. So that proves that the local oscillator here is working. If you can't do that test, then it means you've got a problem in the autodyne oscillator detector. Maybe the connections are wrong, and it's really easy to get them wrong, especially around the coils. Maybe try flipping the connections of this secondary winding. That may help. When the oscillator capacitor is near maximum, your oscillator frequency is around 1 megahertz. You can just see the dial pointer there, just past the 9. If we go up to the top, around 1700, then the capacitor is about halfway out, or just over halfway unmeshed. If you watched Mike's video, you might have noticed that the capacitor here was 1 nanofarad. I tried it and it worked for most of the broadcast band, but I found the oscillator dropped out below about 700 kilohertz, or at least the equivalent of 700 kilohertz, which is about 1.2 megahertz. It meant that I couldn't cover the low end of the broadcast band, so I increased the capacitor to 2.2 nanofarad, and that did the trick. And the oscillator now covers the whole of the broadcast band.
Partly cloudy on Wednesday and 21.
That's for the front end. And as you can hear, there is a significant drop off when you detune it. Then we have here the local oscillator, and that's even sharper. But it does mean that you have to have both these pretty much spot on, otherwise you won't hear a station. Just tuning that a bit off. There's another station there. So you can see it is very sharp.
καύσες στο χέρι, εφημερίδα. Μόνο $250 για καθαρισμό των υδρορών και ηρεμία όλο το Σαββατοκύριακο.
Home and Gardening. Καθαρίζουμε ή αλλάζουμε τα λούκια, απομακρύνουμε γενικά ή πράσινα σκουπίδια, καθαρίζουμε κήπους και οικόπεδα, κλαδεύουμε ή κόβουμε δέντρα.
Another station there.
And expert tips are on your side. Plus, it is the only place to back horses you want to win and lay horses you think will lose.
Don't just watch the carnival, be part of it. Download the Best Air app today. Chances are you...
His priority has always been trade, and he's hawkish on China in terms of what they've done.
The audio quality seems to be a bit better on speech stations than music stations.
Interrupted that. He was looking for it in his first term. On Sylvia's focus, he's more focused on soybeans than democracy in Taiwan.
Exactly. Does he care enough about putting American lives at risk to defend Taiwan?
Merchandise at Australia's best range of personalised racing merchandise.
Now I should point out that this is just off the ferrite rod, no external antenna connected.
Trainer, from classic racing caps, t-shirts, hoodies, vests, jackets and stubby holders. With fast turnarounds and no minimum order quantity. Visit fansave.com.au and look like a real racing fan before you cheer home your next winner. The 2025 New South Wales Senior Open Championship.
Maybe walking on a different creek that you've never been to before and see the ways in which it's similar to or different from the creek that you know.
Mercedes-Benz, for example, with the A45. I mean, that's a hugely powerful, I think it is the most powerful hot hatch that they sell, or that anyone sells, and it's, but, you know, you're talking in the six figures for that, so it starts to step up there a bit too.
Say when it's domestic violence and there's an ankle bracelet on someone who's not allowed to go within, say, 50 metres of a house, they say they can get it in real time and they connect in real time. Now, I don't know whether that's a particular type of ankle bracelet or particular type of technology that is only available for the extremes, but obviously that's an extreme case.
When Darren Hitch had an ankle bracelet on in house detention, he was allowed for half an hour to go downstairs and do laps of a courtyard at his residence.
Well, you're right. We are different. We're raucous. We're coarse. We're showy. We're annoyingly showboaty and loud. We're also overly familiar. We use first names well before most other nationals would do so. I mean, there's a whole lot of American traits that people in my country might not put on any list, but foreigners, when we travel, we're immediately recognized by these traits.
If you did want to connect an external antenna, you can just get a wire from a long wire antenna that's outside, and you can loosely couple it like that. As you might have heard, that caused the receiver to detune. So there we are, you've had to adjust it.
To visit the shop, all the shopping's great, or stay, or just .com.au can help you out. Peninsula Peaks gives you the very best of the modern.
And we'll just remove it. And it's quieter, but that's partly because I've detuned it.
And Kylie's there for the afternoon. She wants to start the hour
I've
with
tuned
you.
it in again. Now, if you've got a weaker signal, the difference will be more marked. With a stronger signal, I didn't find the external antenna was required.
Opened an elevated Italian and five-ding rooftop in the heart of Glen Waverley. I'll ask.
Another possibility is you can couple the external antenna through a couple of turns of wire round over the ferrite rod. One part is earthed, the other part goes to the antenna. Just receiving a country station here. Notice it's different when I'm touching the spindle.
Pop in and chat to the team. The Outerworth Garden Centre on Longwarry Road, Druitt, where quality meets your garden. Visit them 7 days a week. Don't just sit listening to the rain. Do it in your own tank form of rainwater tank. With the biggest range of locally made tanks, they cater for every need.
To summarise, this receiver isn't the most sensitive. As you heard, a bit of distortion, but it's still amazing in what it can do with just 2 transistors. Picks up local stations with no external antenna, with good volume into suitable headphones. Enjoy these videos? Want to start in amateur radio? Well, check out my books, Ham Radio Get Started for USA readers, and the Australian Ham Radio Handbook for those in Australia. For more information, visit my website VK3YE.com or search their titles on Amazon.